Greetings, programs! If you're up there in years like myself, you probably loaded many a machine language program from disk and then had to type SYS followed by some multi-digit number in order to run the program. Most of the programs that I've had to execute in this fashion were typed in by hand from computer magazines, and the most common SYS address for these was 49152. Having to remember the SYS address was a pain in the butt. But I quickly learned to include the address in the file name, and this not only provided an easy way to recall the address, but it also served as a reminder that the program was written in machine language and needed to be loaded with a .8, .1. But this rather clunky way of executing machine language programs was often unnecessary. I'm sure many of you have listed a program only to see the following. Or something similar, or maybe just some text with no line number, like when you list a program generated by Vision Basic, for example. And when you run many of these kinds of programs, execution is typically handed over to some machine language code. This is a much more elegant way of running machine language programs. You type run just like you would with any basic program. The goal of this video is to show you how to create a line like this from scratch for use within your own machine language program, so that all a person has to do is to load your program and execute it with a simple run command. So first, let's take a look at the bytes that make up this basic line so that we can import them into our source code. For D, I like my D, 2049, 2260, prep D, peak D, next. The first two bytes you see here, 11 and 8, are a pointer to the next line of basic code, which doesn't exist actually. So in this case, it indicates where the program ends. So let's bring these two bytes together into a single integer value to find out where they are pointing to. 8 times 256 plus 11. I'm not going to explain the math here. That's a potential topic for another video. Low bytes come first and high bytes come next. So we take the high byte, the 8, and we multiply it by 256. And then we add the low byte to it, the 11. And the resulting address is 2059. Addresses 2059 and 2060 in this particular program are the locations that contain the pointer for the address of a potential third line of basic code. But since a second line of basic code doesn't exist, these two values are both 0. Right here. When the pointer to the next line of code totals a value of 0, it means that we've reached the end of the basic code. Each pointer points to the next pointer, which points to the next pointer, which points to the next pointer, until we end up with two zeros in succession. The 0 at location 2058 is what's known as a line terminator that indicates the end of a line of basic code. Every line of basic code is supposed to have this 0 tagged onto the end. So when you see three zeros like this is pretty much how every basic program is supposed to end. And the end of this basic program is where you'll often find the starting point for some hidden machine language code. In this case, the machine language would likely start at location 2061. Now, locations 2051 and 2052 contain the actual line number for this simple line of code, right here. These two bytes follow directly after the pointer for the next line of code. Again, you would take the high byte, the second byte, and multiply it by 256, and then add it to the low byte, which happens to be 10 here. So multiplying 0 here by 256 and then adding 10 yields our unsurprising value of 10 that you see here. Location 2053 holds our token value for the SYS command, 158. And locations 2054 to 2057, right here, hold the ASCII character codes for the numerals that make up our value of 2061. And at its simplest, this is all the information we need, these 12 bytes that you see here. So let's take these values over to Vision Basic and set things up for our machine language program. And now we're whisked away into Vision Basic. Alright, so let's tell Vision Basic where our program starts. Since this machine language program is going to start with one line of basic code, we need to plug in the usual address of 2049 so that it can load in at the appropriate address when the finished program is loaded into memory. 10 start 2049. And now we plug in our 12 bytes. 20, 8, 10, 0, 158, 50, 48, 54, 49, 0, 0. And press enter. And if we want better clarification, we can combine the low and high bytes like so. And here, well, we'll just change this to 2059. We can't do this with the 10 and 0 here because Vision Basic will just see the 10 and not end up splitting it into low and high values at compile time. Only values greater than 255 get broken up into low and high bytes. And we can also turn our ASCII codes into something more familiar. So we'll go here and change this to 2061 and there. Now, the problem at this point is if we try to execute this code, the computer might crash. I personally don't know because I'm not going to bother trying to run it. So we need a temporary workaround until we are ready to compile our program into a finished file. We know that our machine language is going to reside starting with location 2061, so let's do this. 0 start 2061. And then modify our two other lines like so. Oops. Oops. And the reason why we're adding rim statements is so that while we're piecing together our machine language program, these two lines won't end up being compiled into the mix. I'm just going to whip up a simple program that cycles the screen in border colors. That's the gist of what our machine language program is going to accomplish. But first, I want to preserve the current colors. So let's type 30, 5280, PHA, DA 5381, PHA. Here we're just pushing the two colors onto the stack. And next, 40, increase 53280, increase 53281. Oops, way too much. And here is our actual code that is going to cycle both of the colors. We check location 198 to see if there are any key presses in the keyboard buffer. If not, we cycle back to line 40. Next, LDA 0, SDA 198. In line 50, we're clearing the keyboard buffer so that the pressed key doesn't end up being displayed to the screen when the program exits. Okay, 60, PLA, STA 5281, PLA, STA 5280. And then next, here in line 60, we pull our preserved screen colors off of the stack in reverse order, because what was last put on the stack becomes the first thing you'll pull off. And finally, we're going to exit back to basic with this line here. Now, before I run this thing, if anyone is affected by super flashy stuff, please look away from the screen until I tell you that it's safe to look again. I don't want to drive anyone bonkers like I did in a previous video. Fair warning. Alright, here goes. It's like modern art or something. Anybody want to part with $1 million for this masterpiece? Any takers? Any? Come on. Okay, now I'm going to press the key. And now it's safe to look at the screen again. Okay, so if we want to compile this out to disk so that we can run it from regular BASIC, we need to remove the two rim commands. List. And we just go up here, like so. We take out this one. And we take out this one. Now, having done this, the start address in line 10 here will now override the one in line 0. And if we switch back to the BASIC window, we can load up a compiled version of this to see how things turn out. I compiled this ahead of time. New, load, MELI-X, xe, 8. And again, if you're sensitive, please turn away for a moment, because I'm going to type run. And now you can look back at the screen again. And if we list our program, we'll see something familiar. Voila! 2061 SYS. Now, what if we want to hide the SYS command and display some personalized text instead? Let's head back over to Vision Basic and see what we can do. And here we are. The way to visibly delete the SYS 2061 is to use delete characters. You can place delete characters after the SYS 2061, but when your program exits back to BASIC, you'll get a syntax error. So to prevent this, we need to add a colon and a rim statement. So we're going to take this sign here. Now we need to remove these 3 zeros and place them elsewhere. And then we add 58 for the colon and 143 for the rim token. The delete character is represented by a value of 20, so we need to add 14 of them to fully wipe away the 10 SYS 2061 colon rim that we now have. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I hope I got that right. And now let's add a line of text that we want people to see when they list our program. I'm going to go down here. 22. Hello world. And now we can add back in our 3 zeros. Okay, but we can't just compile this yet. This is because our machine language will be shifted higher in memory, and we now need to know its new starting point. So let's add a tag or a label so that we can track this new location. So I'm going to create line 24. Tag begin. And now let's compile it, but not to disk. And let's see what the value of our tag is. Blitz. It says that our new location is 2089, so we need to change it in a couple places. So I'm just going to list again here. I'm going to go up to 0 here and change this to 2089. And this becomes 2089. But lest we forget, this first value in line 20 needs to be 2 less than the tag's value. Remember, this is our pointer to the next basic line, or in this case, the end of the basic code. So we'll just take away the 2 from 2089 and make 2087. Okay, so if we compile this out to disk, we'll get the following program. Whisking you back to regular basic. And I'll type new. And then I'll type MELI-X2 exe 8. And if we list it, we'll see our wonderful replacement text instead of the SYS call. To show you that the SYS call is still actively there, we'll run it again. And again, turn away from the screen if you're sensitive to this.
Marion, don't look at it. Shut your eyes, Murray, and don't look at it no matter what happens.
R-U-N. Are you ready? Alright, you can look back now. And we're going to go back to Vision Basic. Remember to keep the rem commands in place in lines 10, 20, and now 22 while you're fleshing out your machine language program. And then just remove the rem commands when you're ready to compile everything out to disk. Another important detail in all of this is that you must not use any basic commands from within Vision Basic while crafting a program like this. There are a number of safe commands that you can use that are listed in Chapter 20 of the user manual for Vision Basic. But the issue at hand here is that your basic commands won't have access to the support library when they try to execute, and a crash is likely to result. So what if you want your Vision Basic programs containing basic code to have a personalized text message when people try to list them? Well, currently there is no command or setting to change the default text of Vision Basic 1.1, but that doesn't mean that you can't change the text. The convoluted way to do it is to load your compiled program into the regular basic editor and poke your desired text into the locations ranging from 2074 to 2088. But you can also poke these addresses with a string from within your Vision Basic program, compile it, load it into regular basic, run it a single time, and then save it back to disk. Okay, that does sound a little convoluted too, but it's easier once you set things up. Let's create a tiny program in Vision Basic and I'll show you what I mean. Type new. And 4D equals 0 to 255. Fill. And we can run it just for fun. I don't think this, some people still might be a little sensitive to this. I don't know. If you're squeamish, just turn for a second. And there you go. It's over. Okay, that plays with my eyes. I don't know if it plays with your eyes, but it sure as heck is playing with my eyes. Okay, list. Now let's add our line that will customize things when people list our program in regular basic. And it's quite simple. 0 poke 274. You're curious. Keep in mind that you only have 15 characters to work with. You can pad the rest with spaces if needed, but you'll want to replace all 15 characters. So at this point, I would compile this out to disk, and then load up the program in regular basic. So let's switch windows yet again and load up a compiled version of the program. New, load, curious, vex, 8. And list it. Nothing's changed yet. I want to point out that you will actually count out 16 characters here, but the on that you see here, ON, is a token for the keyword on, and that only takes up 1 byte. And let's run the program. Again, if you're sensitive, turn away. Okay, it's over. And yeah, this pattern, oh my gosh. I don't know. It's playing with my eyeballs. Okay, and now let's list it. You're curious. And this is the point where you can save it back to disk to make it permanent. You can leave the line that edits this text in the program without any issues. It won't harm anything. At some point in the future, I hope to add a way to customize this text so that people can personalize their programs to display something other than Vision Basic 1.1. This might be realized by the addition of a new command or some kind of setting. Alright, we've reached the end of the video. If you're in the mood for some more Vision Basic content, check out Gray Defender's recent unboxing video for Vision Basic 1.1. I'll post a link to it in the description. Also, check out his other great content and subscribe if you like what you see. Anyhow, as usual, I thank you all for watching. Please like and share my video, and definitely subscribe for more similar content. And make sure to visit visionbasic.net.